Good morning, students. Yesterday we have completed multiplication theorem on probability, independent events, dependent events, and some more problems we did. 2 problems we did. So now today, continuing that topic, we are going to do from exercise 13.2 problem number 6 now. So given, you see now the problem number 6, given P of E is equal to 3 by 5 and P of F is equal to 3 by 10 and P of E intersection F is equal to 1 by 5. P of E intersection F is equal to 1 by 5. What is asking? Are E and F are independent or not? This is the question they are asking. So we have to say that these two are independent or not. So events E and F are independent or not means what we said now. So first of all we should check the condition for independent is probability of E intersection of must be equal to probability of E into probability of F. We can say LHS is equal to RHS, then the events are said to be independent events, or otherwise they are dependent events. Okay, so we are already given everything, just substitute. We should know this much only. Their two events are said to be independent if their intersection is equal to their product of probabilities. So P of E intersection F is how much given? 1 by 5. Now 1 by 5 is equal to, what is P of E? 3 by 5. What is P of F? 3 by 10. Now how much you are going to get? It is nothing but 9 by 50. 9 by 50, 1 by 5 both are equal? No. So therefore 1 by 5 is not equal to 9 by 50. This implies E and F are not independent events. E and F are not independent. That is what you have to say. Independent. That's all. So from this we came to know that E and F are not independent. It may be given for 2 marks also. So now it is given, you know. Suppose some working will be given, that time you have to prepare P of E and P of F and intersection F, that they are doing means 3 marks. Directly statement everything is given means 2 marks. So he has already given P of E, P of F, P of E intersection F, and to be say independent, P of E intersection F is equal to P of E into P of F. Again intersection is 1 by 5 and P of E is 3 by 5, P of F is 3 by 10. If you multiply together 9 by 50, nothing will go. So 1 by 5 is not equal to 9 by 50, hence it is wrong. So 1 by 5 is not equal to 9 by 50 means what? E and F are not independent, not equal to. If they are equal means we can say they are independent. So it is not independent. Okay. Now let us move like that. Another problem. Okay, now problem number 7. Before going to the working problems, let me do some like these problems, so that then we can come back to the working problems. So to understand you, I am just explaining this. After 7th problem, let us see now. Given that the events A and B such that, again I will write here given. What is given? P of A. What is P of A? 1 by 2. P of A is 1 by 2 and P of A union B. P of A union B is equal to how much? 3 by 5. And P of B, I will write here, and P of B, probability of B is equal to P. Probability of B is equal to P. Find. Now find P if they are first bit. We have to find P now. When? If they are mutually exclusive. Mutually exclusive. If they are mutually exclusive, what is P value is asking now. So yesterday we had discussed about this. Mutually exclusive means what? Mutually exclusive means, I said, their intersection must be, A intersection B must be equal to 5. Then they are said to be mutually exclusive events. So therefore mutually exclusive means their intersection is 5. So therefore now P of A union B we know it. So P of A union B, how can you write? P of A plus P of B minus P of A intersection B, we won't write. If A intersection B is equal to 5, P of A intersection B is 0. That's why we won't write. But what is A union B is given already? 3 by 5. Write 3 by 5 here. Next, P of A is how much? 1 by 2. What is P of B? P. So this implies P value is equal to how much now? 3 by 5 minus 1 by 2. 3 by 5 minus 1 by 2 means taking LCM, 10 LCM. 5 goes in 10 2 times. 2 into 3, 6. In 2 goes in 10 5 times. 5 into 1, 5. So that is nothing but 1 by 10. 6 minus 5, 1 by 10. So P of A union B is equal to P of A plus P of B. From this we got, this implies P is equal to 1 by 10 when E and F are mutually exclusive ends. That is bit number 1. Here bit number 2. What is bit number 2? E and F are independent. E and F are, not E, A, B, sorry. A and B are independent. If A and B are independent means are independent. So, if A and B are independent, so what will happen? If A and B are independent means what will happen now? We have to see now. So, as we know that if A and B are independent, this implies P of A intersection B must be equal to P of A into P of B. That should be there. Correct or not? If A and B are independent, he said that question, yes, second option. First option is mutually exclusive. The second option is independent. If A and B are independent, then he is asking. So now, how much will be the A of A intersection B? That is the question now. Let us see now. So first question we already did mutually exclusive, and the second bit we are going for the what is given we have to see now. Okay. Now independent means what is P value? So both cases we have to find out. The first case is mutually exclusive. Already we did here. Given P of A union B and P of B, and they are mutually exclusive, implies A intersection B is equal to 5. P of A union B is equal to P of A plus P of B minus P of intersection B generally will be there. But since A intersection B is equal to 5, its value becomes 0. And A union B is equal to 3 by 5. And P of A is 1 by 2. And P of B is equal to P. From this we got P is equal to 1 by 10 over. Next, A and B are independent means their intersection is their product. Their intersection is their product. Now, what we will do now? Now, P of A union B, let us know, because it is given. P of A union B is how much now? According to theorem, P of A plus P of B minus P of A intersection B. Correct or not? Here intersection will come. Because here mutually exclusive. Intersection won't be there. When independent means intersection will be there. So that's why P of A intersection B will come. Okay. What is P of A union B? 3 by 5. You write here. What is P of A? 1 by 2. You write here. What is P of B? We don't know P. What is P of A intersection B? That is also we don't know. But we know that P of A intersection B is nothing but P of A into P of B. Correct or not? Since they are independent events, since they are independent, P of A intersection B can be written as P of A into P of B. That only we wrote. Again, if we simplify further, 1 by 2 plus P minus 1 by 2 into P. Into P. Because P of A is 1 by 2, P of B is nothing but P. So that is what we got it. This is 3 by 5. As usual, 3 by 5 minus 1 by 2 is equal to, in this P of, if you take common, 1 minus 1 by 2. Correct or not? If we take P common here, 1 minus P common means 1 by 2. So 3 by 5 minus 1 by 2, how much? Already we did, 3 by 5 minus 1 by 2 is how much? 1 by 10. So directly I will write now 1 by 10 is equal to P into 1 by 2. Correct or not? 1 minus 1 by 2, 1 by 2. Now this implies P is equal to, cross multiply, 2 by 10. 2 by 10 means how much? 1 by 5. So this implies P is equal to 1 by 5. That's why this is important problem. Good problem, important problem. So I'll write here, very important problem. So what happened now? He has given P of E. He has given he has given, this is, here you continue. This is 7th problem is very important. He has given P of A, he has given P of A union B, and is asking P if 2 conditions. Number 1, if they are mutually exclusive. Number 2, if they are independent. So two things in our mind must be there. If they are mutually exclusive, intersection is 5 and the probability is 0. If they are independent events, wherever intersection is there, we should write product, because that is the definition of the independent events we discussed yesterday. So P of A intersection B is nothing but P of A into P of B. In place of A intersection B, the right, the value are substituted. This is all mechanical. Simply whatever you do, you did it. So if it is independent, we got P value 1 by 5. If it is mutually exclusive, we got P value 1 by 10. These 2 bits. So in 7th problem, 1, 2 bits are important. That's why I am arrow mark I kept here. Okay? Very good. Now let us move to the next problem, which is, we'll see now. I think you understood this because it is very easy also, very good also. Okay? Important. Now let us move to the next point. Here, what is the next point? We'll see now. Next problem. Okay? I'll rub it off. In the meanwhile, you just go through it. I'll rub it the 6th problem. If you want to see the 7th problem, you can see this. No problem at all. Okay. This also I'll rub it off. This also I'll rub it off. So 6th problem we did. 7th problem we did. Now we are, let me see the 8th problem is same or not, anything. 8th problem also we can do. Why? Because it's also same. Problem number 8 now. So what is given? Let A and B be independent events. So given A and B independent events. What is given? You write first. Let A and B are independent events. Independent events. Okay, now? Let given A and B are independent events. So now what is given also? Also P of A, this is, and P of A is equal to 0.3 and P of B is equal to 0.4. Okay, 0.4. Find bit number 1 in this. P of A intersection B. So, question number 1, whenever it is given immediately, first in our mind, what is A and B? Independent. Independent means their intersection is nothing but their product. That you have to remember. So, P of A intersection B, P of A into P of B. Happy. What is P of A? 0.3. What is P of B? 0.4. How much it is? 0.12. 12. 4 3 is 12. You write here. After 1 point, decimal point, 1 digit. After decimal point, 1 digit, multiplication means you should add 1 plus 1, 2. So in result, after decimal point, 2 digits must be there. That's why after decimal point, 2 digits must be there. 0.12. I think you know it. But again, I explained how it has come. Okay. Now, it is students. Now, this is bit 1. Again, the bit 2 is there. If A, P of A union B, I think so. Let me see. Yes. P of A union B. He has given P of A union B. What is P of A union B? Now tell me now. P of A plus P of B minus P of A intersection B. Why I am not writing P of A intersection B means P of A and P of B. Already bit 1 we did, you know. So directly that value I will substitute here. But you are given an exam means this you won't do, you know. That's why P of A into P of B, this you should write. P of A into P of B, 0.3 into 0.4, 0.12 you can write like that in exam. Now it is already we did, then carry forward it. Okay. So what is P of A? 0.3. What is P of B? 0.4. What is P of A intersection B? 0.12. So this is nothing but 0.7 minus 0.12. 7 means 70. To understand you, I will write here so that nothing will happen. 0.7, after that 0. 0.70, 7 is both are same only. So 70 minus 12, how much you will get? 0.12. Then how much you will get, you see now. So that it is easy for you to know that. Okay. So 0.7 0.58. 10 minus 2, 8. 6 minus 1, 5. 0.58 is the answer. P of A union B 0.58. P of A intersection B 0.12. So next, yes, P of A given B. Another point, third point. P of A given B. Every student will get doubt now. Sir, P of A given B means it is dependent events, conditional probability. But here is said A and B are independent events. When they are independent events, so that won't be there, yes, that won't be there. So what I said now, P of A given B, P of A given B, when A and B are independent, P of A given B is nothing but P of A, that is equal to 0.3 over. P of A given B is nothing but P of A. No sir, is something you tell sir, something I'll tell means I'll tell, what is there, no problem here, nothing to worry now. I'll tell you how it has come 0. Why you will write like that. So I'll write here P of A interest A given B. Okay. P of A given B means how much you write? P of A intersection B by P of B. Correct or not? You tell me, my dear students, correct or not? P of A given B, according to the conditional probability, we can write P of A intersection B by P of B. Correct or not? Yes sir. Okay. Then since A and B are independent events, P of A intersection B can be written as P of A into P of B. Correct? Okay. In place of P of A intersection B, I will write P of A into P of B. By how much will come? P of B. Now what happened now? P of B cancel. How much you got? P of A. I told you the same thing. Correct or not? So P of A given B simply is nothing but P of A when A and B are independent, which is their numerator that you can write. So that is equal to 0.3. So now bit number 4 now. Bit number 4, P of B given A. Now you can say, you people can say without any hesitation. P of B given A means how much? P of B. P of B means how much? 0.4. Same thing. Same thing again. Instead of P of B, we will write P of A. P of A will cancel, P of B will be left over. I think you understood. So now this problem is there means they will give for 3 marks means 3 bits. 4 marks means 4 bits. 2 marks means 2 bits. Any 2 bits will give, 2 marks will get it. Any 3 bits will give, 3 marks will get it. Any 4 bits, 4 marks is not there means we need not worry, 1 bit they will remove. Okay, my dear students, I think you understood well. Okay, na? This is also very important problem, good problem. Okay, let us move to the next point. My dear students, you understood. So here what is the only simple concept you have to remember? You have to remember the simple concept is intersection of the two events, independent of the two events is nothing but their product of the A and B, two events. If they are mutually exclusive, intersection will become 0. So phi means probability will become 0. That's why we need not to think about the other one. These two, if you remember, we can do any number of problems. Now we are doing only which is given mathematically. So which is given theoretically, that is also will do. Because if you are strong enough to do these problems, then we can do those problems. Otherwise, first only if I go there, already I given one problem example yesterday. Now I don't want to confuse you more also. Okay, let us see now. Like that, is there anything? I'll see now. So problem number 8 is over. Now we'll go to the problem number 9. Problem number 9 also we can see that. Okay, problem number 9. What is problem number 9 is given, we'll see. If A and B are two events such that, okay. So problem number 9 is nothing he said. He didn't mention that they are independent events. He didn't mention that they are mutually exclusive events. He simply that they are events. Okay. So if A and B are two events such that P of A is equal to 1 by 4. So given P of A is equal to 1 by 4. P of A is equal to 1 by 4, comma, P of B is equal to 1 by 2. P of B is equal to 1 by 2. And P of A intersection B is equal to 1 by 8. And P of A intersection B is equal to 1 by 8. Okay. So now what happened now? P of A is equal to 1 by 4. P of B is equal to 1 by 2. and P of A intersection B 1 by 8. Now what do you want? He said that find probability of not A and not B. Not A and not B. That is he has given. He said that probability of not A and not B. I will write here. This what I is asking now. Not means complement. Not A. I don't want A. I don't want A means it's complement. Means A bar or A dash. You can put A dash or A bar. Generally we will write like this. A bar. Next here is there not B. Same B bar. But in between what is there? And. And means intersection. And means intersection. So this one word you are given, we are connected to this point. So P of A bar intersection B bar is asking. Now the question set theory, this is all. So now P of A bar intersection B bar means what? I will write here. So P of A bar intersection B bar. If they are independent given means A and B are independent events means we write P of A bar into P of B bar over. But it is not given, none mention anything. Why? Because it is there. Now I will tell you, we can check whether the given events are independent or not. We can check, correct or not. How will check, sir? Their intersection must be there, their product. What is P of A intersection being given? 1 by 8. What is P of A given? 1 by 4. What is P of B given? 1 by 2. 1 by 4 into 1 by 2? 1 by 8. 1 by 8 is equal to 1 by 8. Yes, they are independent events. My dear students, you understood now. So, from the given data, I checked that P of A intersection B is equal to P of A into P of B or not. Yes, it is. Then they are independent events. If they are independent events, their complements also independent event only. Therefore, how we write P of A intersection B, P of A into P of B? In the same way, we can write P of A bar intersection B bar as P of A bar into P of B bar. Correct? Now the question is, sir, P of A bar I don't know, but we know it. 1 minus P of A. Complementary means what I said. Probability of success plus probability of failure is always equal to 1. Whenever you want probability of failure, it is nothing but 1 minus probability of success. That's only I wrote 1 minus P of A. Now P of B bar means what? 1 minus P of B, my dear students. Okay, sir. Now what is 1 minus P of A? P of A is 1 by 4 means 1 minus 1 by 4 into 1 minus P of B 1 by 2. So how much you are going to get, sir? 4 minus 1, 3 by 4 into 1 by 2, which gives 3 by 8. Which gives 3 by 8. So the problem of getting problem number 9 is 3 by 8. Answer is over. Problem is over. Because nowhere it is given mutually exclusive or independent events, but from the given statement I observed that their intersection is their product, henceforth they are independent events. They are independent events, their complement also independent events. Simply I wrote, I got it. Okay, sir, we are also happy that you told like this, but if they are not independent means what to do, sir? You tell me. Suppose here he got it. For example, they are not independent. 1 by P of A intersection B is not equal to P of A and P of B. In that case, we have to find out P of A bar intersection B bar. Then how to do, sir? Okay. Or, I'll tell you. Or, here what is there? P of A bar intersection B bar. If it is independent means directly you can write like that. Or, 1 minus P of A union B whole complement. P of 1 minus P of A union B. A bar intersection B bar is equal to 1 minus P of A union B. Okay. Now, so what is P of A union B? Well, right now this implies P of A union B is nothing but P of A plus P of B minus P of A intersection B. Okay. What is P of A? 1 by 4. What is P of B? 1 by 2. What is P of A intersection B? 1 by 8. What is LCM? 8. In 4 goes in 8 2 times. 2 into 1 2. 2 goes in 8 4 times, 4 into 1 4, minus 8 goes in 8 and 1 term. So 4 plus 2 6, 6 minus 1, sorry, 6 minus 1 5, 5 by 8. Okay, you got it, 5 by 8, what? P of A and B. So now P of A bar intersection B bar is equal to 1 minus P of A and B. What is P of A and B? We got it, 5 by 8. 1 minus 5 by 8 means what? 8 minus 5, 3 by 8. We got it, you know. Same, yes, see, 3 by 8 we got here, 3 by 8 we got here. So, if you are not able to find out that they are independent, if independent means this is very easy to do it. Suppose in any case if they are not independent, if you think like that, we can do like this. If they are independent also you can do like this. Not independent also you can do like this. But instead of finding A union B and subtracting directly, you can P of A and P of B, got it if they are independent. So, my dear students, so you must be very careful while doing it. If it is independent, one step. In entrance level, time wasting otherwise. So, that's why it is. So, both method I told you. If independent, if not independent also, you can do like this. So, answer will be the same. Okay. My dear students, understood, you know. So, tomorrow P of A bar intersection B bar is nothing but 1 minus P of A union B. Okay. I think you understood well. This is the problem number 11. I think so. Yes, 9 I said. Next problem. Problem number 10 also we'll see now. Problem number 10. I'll read here. I'll do here. You see now. What is problem number 10? I'll write here. Given. It is given. Here also same. Events A and B are such that P of A, given P of A 1 by 2, yes, comma P of B 7 by 12. Okay, P of B 7 by 12. Next, and P of not A, P of not A or not B, or not B is equal to 1 by 4. P or not A or not B is equal to 1 by 4. State whether A and B are independent or not. That's what is given. State whether A and B are independent or not. So that is the first question is given now. State whether A and B are independent or not. Okay. Now let us see how far it is correct like that. Now first of all, we are doing the problem number 10. Yes. Problem number 10 we are doing now. Let us see now. Given P of A, P of B. Here is it. P of not A and not B. So P of A bar intersection B bar, which can be written as 1 minus P of A and B. Okay. Here, what is given now? P of not A means A complement. R means union and B complement. This is given 1 by 4. My dear students, now you understood, I think. P of A is 1 by 2, P of B is 7 by 12, and P of not A means A complement union B complement. Here intersection given, their union given. But here also you cannot check whether they are independent or not because we don't know the intersection there. So now the question has come now, because independent not there means how to do. Now can you tell me how it will get it? How will you? By seeing this. Now this implies P of A bar union B bar. Can you tell me how much 1 minus? 1 minus? You tell me. How much will P of A bar union B bar? How much it will be? See, P of A bar intersection B bar means 1 minus P of A union B I told. Now here what happened now? P of A union B means how much you can write now? You tell me 1 minus P of. Okay. Two things are there. Without knowing also you can do that. That is also I will tell you. Sir, now I got confused, sir, whether to 1 minus P of A intersection B should I write or A union B should I write something. I confused, sir. Okay, no problem. Now leave this. Leave this. A bar and B bar is there. Instead of A, B, you write A bar and B. A union B in your method, in your general method, you know it, A union B, what is that? You write that only. P of A bar plus P of B bar minus P of A bar intersection B bar. Correct or not, you tell me, my dear students? If they are, if A bar you treat as A, B bar you treat as B, then P of A union B, P of A plus P of B minus P of A intersection B, I wrote now. Correct? Okay. Now, here, already given, no? Not A or not union, how much? 1 by 4. Right here. What is P of A bar? 1 minus P of A. You know that complement I told you just now. So 1 minus P of A. What is P of B bar? 1 minus P of B minus P of A bar intersection B bar, which is there, which you don't know. Okay, let it be like this. Doesn't matter. Bracket close. 1 by 4. Not bracket. This is separate only. Okay. 1 minus 1 by, what is P of A? 1 by 2. 1 minus 1 by 2. 1 by 2 only. 1 minus 7 by 12. 7 by 12 means 12 minus 7. 5. 5 by 12. My dear students, I think you understood. 1 minus 7 by 12. 12 minus 7. 5. 5 by 12. Otherwise you write minus P of A bar intersection B bar. Okay. Now, this implies how much you are going to get? 1 by 4 is equal to 12 LCM. In 12 2 goes 6 times and 12 goes 1 time minus P of A bar intersection B bar. Okay. Now this implies 6 plus 1 by 4 minus 6 plus 5, 11 by 12. You write like this is equal to minus P of A bar intersection B bar. So now you tell me 12 LCM. In 12 4 goes 3 times, 3 minus 11. 3 minus 11 is equal to minus P of A bar intersection B bar. Now 3 minus 11 means how much, amma? Minus 8. Minus 8 by 12 is equal to minus P of A bar intersection B bar. Okay na? So here minus cancel. Here 2 4s are side 3. So this implies, I don't have space, I'll write here. This implies P of A bar intersection B bar is equal to how much? 2 by 3. Here na? 2 4s are 8, 3 4s are 12. So 2 by 3. We got it. Now we got A bar intersection B bar. We know A bar plus B bar. Then we will get directly. How much you will get now? You tell me. So P of A union B B bar. P of A. What is P of A bar? 1 by 2 plus P of B bar 5 by 12 minus P of A bar intersection B bar 2 by 3. This implies 12 LCM. In 12 goes 2 goes 6 times. In 12 1 time. 4 times 4 to just 8. So 6 plus 5 11. 11 minus 8. How much? 11 minus 8. 11 minus 8. 3. 3 by 12. 3 by 12 means how much? 1 by 4. Okay na? Now you tell me they are independent or not is asking now. They are independent or not asking means what you should say? P of A intersection B is equal to P of A into P of B or not. P of A 1 by 2. P of B 7 by 12 means how much? 7 by 24. P of A intersection B, whether 7 by 24 will come? We won't come because P of A union B over bar is equal to 1, won't get it. So therefore finally what will say? The given events are not independent. Okay, that is one method, general method. So let me rub this one so that once again I explain this. So let me rub this. Okay, go through it once again what I said now. So you will come to know. You should not get confused. See. This is exercise 10 point, we did 10th problem we are doing now. In that is asking whether they are independent or not. So finally we should able to say that P of A into P of B is equal to P of A intersection B. Correct or not? So P of A intersection B means P of A bar union B bar. How much we got it? You tell me. 1 by 4. So now finally P of A bar intersection B bar, how much we got? 2 by 3. What we did now here? Again to prove unnecessarily we did. I forgotten here. P of A union B whole bar 1 by 4 already is there, y 100. Again we are showing 1 by 4. So this step is not necessary. I have not seen this. Okay? So not necessary. Okay, na? My dear students. So we got P of A bar intersection B bar is 2 by 3. That we wanted. Now P of A union B is equal already 1 by 4. From there only we got it, P of A bar intersection B bar we got it. And P of A bar we know, P of B bar we know. Now what? Now he is asking P of A intersection B, how much you can tell. A intersection B means how much? 1 minus P of. Correct? We have to put that one. Then P of A. Finally, P of A intersection B is equal to P of A into P of B. What is P of A? 1 by 2. What is P of B? 7 by 12. So now how much? 7 by 24. Whether P of A intersection B is 7 by 24? If that is the case, then they are independent events. If they are independent events, this won't come. If they are independent events, P of A bar into P of B bar should be 2 by 3. Correct or not? See, I am not going to find out intersection value also. Logically I am saying, that also, if you don't know formula also, no problem. So logically what I am saying, if A and B are really independent events, according to the statement, what we have to find out, if you say that they are independent, then P of A bar intersection B bar must be P of A bar into P of B bar. P of A bar into P of B bar, how much is there now? P of A bar 1 by 2, P of B bar 5 by 12. So how much you should get? 5 by 24. But how much you got? 2 by 3. So they are not independent. Over. Correct? Huh? So we need not to check. You need not to find out the intersection B also. So simply, as I said earlier, you check P of A bar intersection B bar is equal to, instead of checking this, P of A bar intersection B bar is equal to P of A bar into P of E bar over. This one theorem is there. I not explain, example is there. I'll explain afterwards. So P of A bar intersection B bar is equal to P of A bar into P of E bar. Then this is correct, means this is correct. P of A intersection B, I am having confusion. How to do, what to do. So no confusion. You got A intersection B. Now you see, A intersection B, about 2 by 3 is that. What is P of A? 1 by 2. What is P of B bar? 5 by 12. So 5 by 24 will come. This is not correct. So this implies what? A bar, A bar, B bar are not independent. Respectively, A comma B are also not independent. A comma B are not independent events. Okay now? So see, without any confusion, I will tell you. So I don't want to say that 1 minus P of A union B whole bar. I don't want to compliment that. I didn't say. So this is given. This we know addition theorem. From this, I find out P of A bar intersection B bar. Now I want to check P of A bar intersection B bar is equal to P of A bar into B bar or not. If so, A and B are also independent. Because one theorem is there. If A and B are independent, their complement also independent. That is the theorem. So if their complements are independent, then A also independent. So here I didn't get it. So they are also not independent. Over. Here you need not to find out A intersection B, will check whether correct or not. Okay. That is also will know. Because set theory you should know more. Afterwards I will tell you in entrance exams comes how to find out that also. Okay. My dear students. Let us move to the next one. Next problem is there, anything is there, we will see that we will do it. Otherwise, I will give that one as homework. You please do that homework. Problem number 11. Problem number 11, I will give as homework. Please do, all of you, so that will be no confusion with you. What is problem number 11? Given two independent events A and B. So, given A and B are independent events. Independent events. Okay, na? Given A and B are independent events. So what is said that P of A 0.3 and comma P of B 0.6. So what is asked to find it? Number 1 bit P of A and B. P of A and B means what? P of A intersection B. So next second bit P of A and P of A and not B. P of A not B. Third bit. P of A or B. A or B means A union B. Fourth bit. P of neither A nor B. P of neither A nor B. You please do this one problem. Homework. Okay, now we'll discuss you. So 1, 2, 6, 7, 8, 9, 10, 11 we did it. Means what? All general problems are gone. Now we have to do working problems. So in next class we'll do the working problems. Okay, my dear students, once again, if you follow properly, listen carefully, then you can come to know these theorems very easily. So we have so far learned conditional probability and independent multiplication theorem on probability by using independent events. So once again, conditional probability means what you learned: P of A given B is equal to P of A intersection B by P of B. That is conditional probability we learned. And then multiplication of theorem also we learned. P of A intersection is in two cases. If A and B are independent events, their intersection will become as their probability or their product, P of A into P of B. So in this exercise what you learned, he is giving A and B an intersection, is asking whether they are independent or not. If they give like that, it is easy for us in that equation whether correct or not. So now by using set theory, A given, A not given, either A not B not complement, like that he has given problems. So from this also, without any problem, we find straight away, we find out they are independent or not. Okay, here this problem what you should know: if A bar comma B bar not independent events, A and B also independent events. If A bar comma B bar not independent events, then A and B also not independent. That's the theorem I took and I proved, and basing on this theorem, next class we will do it. So my dear students, please go through all the videos once again which you did and which you have seen, that again practice it, definitely will get it. Okay, no problem. Again we'll see the next video. Thank you.